for introducing me and this opportunity. So welcome everybody to today's session. I believe some of you have attended a few other sessions on numbers before this. So today we'll be primarily revolving around the concepts on base systems. And after that, we'll also be discussing a couple of problems on the numbers topics that you all have already learned in the previous few sessions. This session is brought to you by me, Nilanjan Dutta, a Calendar percentiler. And today we'll be stressing more on the base systems areas. So the first thing that we'll do is we'll start with what is base systems all about before we move on to some questions to practice or illustrate this concept. So to start with, what is meant by base systems? So normally when you write down a number, like 74, so what do we understand? So when you write down number 74, we always by default assume what is called decimal notation, which means base 10. Even though we do not say it's base 10, but when we write down a number, we always write it down as by default base 10. Now, the same number could have been written in some other base as well. So what does that concept of some other base mean? So in the decimal number system, what we usually have is numbers in the range of 0 to 9. So basically when you write a number, any number in base n, what happens is you have the digits from 0 to n-1 allowed. So in decimal notation, because the base is 10, we allow numbers from 0 to 9, which is why you'll find that the largest two-digit number possible in decimal notation is 99. After that, we again go to 100. Why? Because you are in base 10. Now, let's take the number 74. So this is by default assumed to be in base 10. Now, what would have happened had we had to represent the same number 74 in a different base? So for example, let's take the number 74 base 8. Are these two same? 74 base 10 and 74 base 8. Are these two same? They are not the same. Why are they not the same? So why is 74 base 10 and 74 base 8 not the same? Because the base is different. So now when I say the base is different, we need to understand what is the implication of numbers written in a particular base. So when I say 74, basically we say that the number 74 is basically 7 into 10 plus 4, correct? And that is why we say the number is 74. That is 7 into 10 to the power 1 plus 4. Similarly, if you write in base decimal notation, if you write a 4-digit number like 4126, what do we mean? 4000, that is 4 into 10 to the power 3 plus 1 into 100, that is 10 square, plus 2 into 10, that is the 10th digit, plus 6, which is your units digit. So that is how we denote numbers in decimal notation. Now the question is, how will it be denoted in some other base? So let us take a sample base like base 8. How will 74 in base 8 be written? So now if the base is 8, what you do is 7 into 8 to the power of 1 plus 4. Unlike in base 10, where what we did was 7 into 10 to the power 1 plus 4. Here what we'll do is 7 into 8 to the power 1 because the base is 8. So 7 into 8 is 56 plus 4, that is 60. So this number is effectively 60 in base 10, whereas this number is effectively 74 in base 10. So for any other base other than 10, what you do is you multiply this by the base right instead of powers of 10. So similarly, 4126 if I write it in base 8, then how would it be? 4 into 8 to the power 3. And then 1 into 8 square plus 2 into 8 to the power 1 plus 6. So basically, wherever I'm doing into 10 cube because of thousands digit, into 10 square because of hundreds digit, tens digit I'm multiplying by 10 to the power 1. There, instead of that, I'll multiply it by the base, that is n. So here what I'll get is 4 into 8 cube, which is 512. So 4 into 8 cube is 512. 1 into 64, 2 into 8 plus 6. So how much does it come out to be? 4 into 512 plus 1 into 64 plus 2 into 8 plus 6. So that is, it comes out to be 2134 in base 10. So the same number in base 10 is worth 4126. But when written in base 8, it is worth only 2134. So that is where the significance of the base of the number is so very important. Any questions thus far, anybody? On how you're representing a number from one base to another, the difference?
So guys, you can unmute yourself while talking. And Nilanjan, for your information, people are commenting on our chat window as well.
I'm trying to figure out how the chat window is.
You can click on the triple dot options and you can opt out the chat window, or it's on the top if you're using mobile phone.
No, I'm presenting from my laptop. So
okay.
There is last view, custom show presenter window, screen, arrow options, subtitle settings.
Is there anything on the top?
Last view,
hide conversation. Left to the red button. Second left to the red button.
It's fine. We can continue. I mean, if anyone has any question, I mean, you can unmute yourself and you can ask that straight away.
No, I can see the window when I'm going out of presentation mode. Then I can see the window. Okay. I cannot see the window when I'm in the presentation mode.
Yeah, that would be actually that won't be possible. So guys, please cooperate and ask your questions by unmuting yourself and quickly mute yourself once you're done. All are aligned, right? कोई तो हाँ बोल दो unmute करके. Anyone can say yes.
Yeah, we can.
Perfect.
Yes,
okay.
चलो नीलांजन कंटिन्यू करते हैं.
So y'all can see my screen again, right?
Yes.
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 Okay. Now, so usually when it comes to exams, we talk of representing numbers in the range of base 2 to base 16. So 2 to 9 is the portion which is easier. That is the example that I showed, base 8. The difficult portion comes when you're writing numbers in base 10 onwards, that is 11 to 16. Why is this difficult? Because the moment you go into base 11 to 16, you do not know what are the digits to allow. For example, if I look at base 16, the biggest problem is I have to allow digits from 0 to 15. So how do I represent digits from 0 to 15? So that is by using digits from 0 to 9, and after that using alphabets as follows: A, B, C, D, E, and F. So the pattern that is followed is, first you use 0 to 9, and since you need to represent every character by a single character, you have to go into alphabets after that. That is A, B, C. A is standing for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, F stands for 15. So that is the way you represent numbers. So for example, an example of a number in base 16 could be something like BD4. What does BD4 in base 16 mean? It means B stands for 11, that is 11 into 16 square. Then you have D. D is 13 into 16. And then you have 4, which gets added. So 11 into 16 square. 16 square is 256. So 16 square into 11 comes out to be 2816. 13 into 16 is 208. And then you add 4. So if you add all this up, you end up getting 3028. So this is the actual value of the number, which can be denoted as BD4 in base 16. Similarly, had it been base 14, then the only difference is you would have allowed digits from 0 to 9, and then A, B, C, and D, that is up to 13. So always remember, you're only allowing characters from 0 to n-1. If it is base 14, you're allowing up to 13, which is up to D. If it is base 15, you're allowing up to F. If it is base 12, you're allowing up to B, and so on. If it was base 8, then you can have a maximum of 0 to 7. So that is the way the concept of bases are working. So can anybody tell me what are the digits that are possible in base 3? In base 3, what are the digits possible?
0, 1, and 2.
Correct. In base 3, you can only have 0, 1, and 2. Similarly, in base 9, what are they possible?
0 to 8.
0 to 8. Similarly, in base 15, 0 to
D.
not D. Base 15 means till 14.
14.
That is E. So basically, all numbers from 0 till 9, and then A, B, C, D, and E will be allowed because E is 14. So basically, all characters effectively from 0 to 14 are going to be allowed. Is this clear, the concept of bases?
Yes.
Moving on to other detail like converting a number from one base to another base. But before that, any questions thus far?
No, sir.
Okay. So let us look at converting a number from one base to another. So let's take a number like 92. This is a number in base 10. Now the question is, how do I convert this to, let's say, a base 8 number? Anybody? How do I convert this number from 92 to base 8? What were your steps that I can use?
Look for the maximum power of 8 into something that you can do here. For example, 1 into 8 to the power 2, that is 64.
Okay. And then?
Then you subtract that value from this value and then go on for the subsequent powers of 8.
Okay. So what he's saying is absolutely right. That is, you look for which power of 8 is closest to 92. The powers of 8 are 1, 8, 64, 512 and so on. So which power of 8 is closest to 92? 64. So that is basically the third digit. So this digit will be 1. What is the remainder remaining? 28. Now 28 is less than 64, but it is more than 8. How many times 8 will divide 28? 8 into 3 is 24. So basically this digit will be 3. That is 3 into 8, 24. What will be the remainder? 4. So this 4 will go into the units digit. Alternatively, what he could have done is this. Keep successively dividing. If I divide 92 by 8, what is the quotient? 11. What is the remainder? 4. Again, if I divide 11 by 8, quotient 1. Remainder 3. Again, if I divide it by 8, 0. Remainder 1. So your number is nothing but, in this sequence, 134 base 8. So that is how you can denote any number from base 10, that is decimal notation, to base n. Is this clear? Let's look at a similar number, one more number. Let's say 76 base or 270. Let's take a larger number, 276 base 10. And let's say I want to convert it to base 7. So what do? I keep dividing 276 by 7. So 276 by 7 is how much? 3 here, 21, this is 66. So that is 9. The remainder is 3. Then again I divide by 7, I get 5. Remainder 4. Again I divide by 7, quotient is 0, remainder is 5. So the number becomes 543 base 7. Is it clear now? How am I differentiating a number from a particular base to another base? From base 10 to another base?
Yes, sir.
This is the way it will work for every number. Now what we can do is let's look at a more difficult scenario. That is a number like 496 in base 10, which I want to convert to, let's say, base 14. Then what do? Same procedure. You keep dividing by 14. So how much is 496 divided by 14? 3 here, 76. 76 is 5 here, and a remainder of 6. Then again you divide by 14, you end up getting 2 here and a remainder of 7. Then again you divide by 14, you get 0 here, 2. So effectively the number becomes 276 in base 14. Now let's say the same number had been 502. Then what would have happened? When I divided by 14, I would have still got 35, but my remainder would have been 12. So that means 2, 7 and 12. So how would I have represented that? 2, 7 and then what alphabet would have come? What alphabet would have come at the end?
C.
C, because C stands for
C.
12. So that would have been 27C in base 14. So that is how you convert numbers from base 10 to any other base. I hope this concept is clear to everybody.
Yes.
Next, what we do is converting a number from base n to base 10. So this is something we've already seen an example earlier. Free to CA, let's say in base 15. That is 15. So now if I want to convert it to base 10, how do I do it? Three into 15 to the power cube, 2 into 15 square. C stands for 12, 12 into 15, and A stands for 10. So 3 into 15 cube is 10,125. 2 into 15 square is 2 into 25, that is 450. 12 into 15 is 180, and you have 10. How much does it add up to be? 190 plus 450 is 640. 640 plus 10,125. So that is 10765. This is the number in base 10. Have you noticed something? That whenever I am converting a number from a certain base to a smaller base, the value of the number is increasing. Here we had a 4-digit number. Here we have a 5-digit number. Similarly, when we are converting from a smaller base to a larger base, the number is decreasing. So this is something you need to always remember when you're converting a number from a smaller base to a larger base, the number increases. Sorry, number decreases. Smaller base to larger base, the number decreases. When you're going from a larger base to a smaller base, the number will increase. This will hold true for every possible number. Look here, when you went from a particular base to a smaller base, the number increased. 134 is greater than 92. When you're going from a base 10 to base 7, again the number is increasing. This will hold true in every case. When you're going to a larger base, the number will decrease. When you're going to a smaller base, the number will increase. So any questions thus far on this concept?
No, sir.
Is everybody able to follow the class?
Yes, sir.
Yes.
Yes.
Anywhere where you're facing difficulty, just make sure that you are stopping me and you're letting me know. Now, what happens in base 2? Base 2 can have only 2 digits possible, that is 0 and 1. So let's take a base 2 number. Now if I want to convert this number from base 2 to, let's say, base 8, how do I do it? How do I convert the number from base 2 to base 8? Anybody?
First, we will convert the number from base 2 to base 10, and then from base 10 to base 8.
How many of you agree with her that this will always happen, that if you can go from base 2 to base 10 and then to base 8? Will this work for every number?
Yes.
That is right. Whenever you're going from base X to base Y, always remember the easiest way to convert it is stop at base 10, because that is something we know the formula, how to convert from base N to base 10, and then from base 10 to the other base, let's say base Y. That is the easiest way out. Having said that, in certain cases, there could be a simpler way than going for this technique. And one such question is this. Note, even for this question, going from base 2 to base 10 and then base 10 to base 8 would have worked. But there is a simpler technique of doing that immediately without putting in much effort. Can anybody tell me how can we do that? Note the relation is because n here, 8 is a power of 2. What is 8? 2 to the power of 3. So how can I represent the numbers? What you can do is you can group the numbers in groups of 3. Since 8 is equal to 2 cubed, what you can do is simply group the numbers in groups of 3. So what is the first part? That is 4 plus 1, which is 5. Second part, 4 plus 2, that is 6. Third part, 4, and all the others are zeros. So 4. So effectively, you can write the number as 564 base 8.
This will also work for every case?
No, this will work for any from base 2 to any power of 2. The reason why this is I'm taking 3 digits at a time is because 8 is equal to 2 cubed. Let's take the same number. Let's take the same number. Okay. If I had to convert it to base 16, how would I have done it?
Groups
If I
of
had
4.
to convert it to base 16, how would I have done it?
Groups of 4.
Groups of 4. So this is 1. This is 4, 2, 1. That is 7. This is 4 only. So that is 174 base 16. Is it clear?
Base will also be always be 2, or it can be any other power of 2 and then to someone else.
So basically this will work in case this value is a power of this value. Then it will work. So for example, if I'm writing a number in hundreds, then basically what is happening compared to 10? What is happening? Since 100 is 10 square, I'm taking 2 digits at a time, correct? Instead of 10. The same thing is happening here. If I had to write a number in terms of thousands, what would I have done? I would have broken up into parts of 3. correct? From the 3 digits from the right for every 1000. The same thing is happening here. For 8, I'm doing it in 2 cubes. I'm taking 3 digits from the right every stage. 16, 4 digits from the right. 4, 2 digits from the right. And I'm keeping on breaking the number and I'm converting it. Just like I would have done for 100 in terms of 10. 100 equals 10 square. So I would have taken 2 digits from the right at a time.
All right, got it.
Okay, just going to happen when one number is a power of the other number. Similarly, if I had to convert 564 base 8. So for example, if I wanted to convert, let's say, BD 3BD base 16. If I wanted to convert to 2, how would I have done it? I would have first broken 3. How can 3 be broken? 0, 0, 1, 1. How can B be broken? B is 11. How can 11 be broken? 8 plus 2 plus 1. That is 1, 0, 1, 1. How can D be broken? D is 14. That is 8 plus 4 plus 2 plus 0. So the entire number will then become as follows: 1, 1, 1, 0, 1, 1, 1, 1, 1, 0. Is it clear? This zeros at the start will not be included. So it will be a number basically starting from here to here. 1, 1, then 1, 0, 1, 1, then 1, 1, 1, 0. Okay, this is how you can convert from 16 to 2 as well. Note, you could have done by this technique as well. It's just that this will be much quicker. No other change. Next, what we'll do is addition of numbers in base n. So let us take n as 8 and let us take 3 numbers. What will be the sum of these numbers in base 8? How do I do that? How do I do that? Sum of these 3 numbers in base 8. All the numbers are in base 8. I need to add them up in base 8 again. How do I do that? Any suggestions, anybody? Each of the numbers are in base 8. I just simply need to add those numbers.
Simply adding them.
What? Sorry, I could not get you. Could you come again?
Simply adding them.
Okay, so how do I add? 3 plus 6 is 9 plus 5, 14. So what do I write here? 4.
No, the carry will be from 8.
That's correct.
Like 6. The carry will be 6.
I think
That is right. So what he's saying is, in base 10, if I was adding, so let's say this is base 10 addition and this is base 8 addition. In base 10, what would I have done? 3 plus 6 plus 5 is 14. So I would have given a carryover of 1 and I would have written 4 here. But here in base 8, since I'm getting 14, I will write 6 here and a carryover of 1, because the carryover of 1 denotes 8. So 14 can be broken up as 8 plus 6. So carryover of 1 and 6 comes here. Unlike for 14 in base 10, what we are doing is carryover of 1 and 4 coming here. Next, what do I do? 1 plus 4 is 5, plus 7 is 12, plus 3 is 15. So what do I write here? What do I write here? 7. So 15 is 8 plus 7. So carryover of 1 and I write 7 here. Now what is the total for this digit? 1 plus 5 plus 2. That is 8. So what do I write here?
1, 1.
1.
1.
1 1.
1 1. No, not. I don't write 1 1 here. How can you represent 8 in base 8?
1
1
0.
into 8 plus 0.
1
So it
0.
will be written as 1
1
0.
0.
Just like had the total been 10, I would have written 1 and 0, right? Had the total been 10 in base 10, I would have written 1 and 0. Similarly, here I'm getting 8. It will be 1 carryover and 0. So basically, 1 more carryover and it will be 0. Clear? So getting the number as 1076. Is it clear how we did this addition in base 8? Or do I need to explain this again?
Can you please explain it once, please?
Okay, sure.
Can you give a different example?
Yes.
Oh, okay. Okay. Let me not erase this example. Let this stay. I'll remove the right hand side one because I believe you all are clear on how to do it in base 10. So let me remove the right hand side example. Okay, so let's do something in base, a larger base. Okay, that would be more challenging. 12. Let's say in base 12. So the number is, let's say, 6A 5 9 0 7 B 2 4. Okay, let's take this example and we're adding numbers. So first thing, unit digit, what is happening? 5 plus 7, 12 plus 4, 16. How can I represent 16 in base 12? 12 plus 4, right? 12 into 1 plus 4. So that means this is going to be 4. There'll be a carryover of 1. Then next comes A. A is how much? 10. So 10 plus 1, 10 plus 2, that is 12, plus carryover of 1, that is 13. How can you represent 13? 12 into 1 plus 1. So this will be 1 and there will be a carryover of 1. Next, what happens? 6 plus 9 is 15 plus 11 is 26. 26 plus a carryover of 1. That is 27. How can you represent 27? 12 into 2 plus 3. So you write 3 here and you're getting a carryover of 2, which will finally add on to your leading digit. So effectively, your number in base 12 will be 2314. Is that clear now?
Yes.
How we are doing this addition?
Yes.
All we are doing is, had it been base 10, I would have written 10 into 2 plus 7. But here I'm writing 12 into 2 plus 3. So all time, every time the carryover is determined by power of 12 instead of, not power of 12, multiple of 12 instead of multiple of 10. Next, let us look at subtraction of numbers in base n. So let's take a number 738 and 465. Okay, and let's say we are doing this subtraction in base 9. How do we do this? What will be the last digit? Anybody?
2.
The last digit, what will be this digit? I'm doing a subtraction in base 9. 8
3.
minus 5. That is 3. Correct? Next time what is happening is I'm getting 3, whereas I'm subtracting a larger number. So what do? I cancel this, I make this 6, and I add a carryover which is 9 to this. So if I'm subtracting 1 from here, I'm adding 9 to this. So that is 9 plus 3, 12, minus 6, which is 63. And then 6 minus 4 is 2. So that is 263. The only difference is, had it been a decimal notation, I would have added 10 here. Whereas, since this is in base 9, when I'm subtracting 1 from the previous digit, I'm adding 9 here. So 9 plus 3 minus 6 is 6. So that is how I'm getting 6 here. So I'm getting the number as 263. Is this clear, everybody?
Yes.
Yes, sir.
Do you all need any other examples of subtraction, or is this enough? Or you think one more example is needed?
One more example is needed.
Okay. Let's take a number in base 13. Okay. A9B. From there, let's say I'm subtracting 6 to C. So here the base is 13. So first digit is B. B is 10. B is 11, whereas C is 12. So obviously B is less than C. So what do? I reduce this to 8 and I add a 13 to B. So B plus 13 is 11 plus 13, that is 24, minus C, that is 12. Which means 24 minus 12 is 12, which means this value is going to be C. Next, what do? 8 minus 2, which is 6. Then A minus 6, A is 10, 6 is 4 less than 10. So the answer is 46C. So that is how you're subtracting in base 13. Multiplication and division is also a very similar. Multiplication of numbers, what do? When I'm multiplying, let's say 8 into 7 in base 10, what do? I get 56. Or rather, let's say when I'm doing 18 into 7, what do? 7 into 8 is 56. So that is 6 and carry over of 5. Then 7 into 1 plus 5, that is 126. Now let's say I'm doing the same multiplication in base 9. That is 18 into 7. How much will it be? Anybody? Same multiplication, 18 into 7 I'm doing in base 9. Eight into 7 is 56. 56 is 6 into 9 plus 2. The nearest multiple of 9 to 56 is 54. So 6 into 9 plus 2. So remainder will be 2. Here there will be a carryover of 6. 7 into 1 is 7 plus 6, that is 13. 13 is how much? 1 into 9 plus 4. So it will be 4 carryover of 1, which is 142. So effectively the answer will become 142 in base 9. So that is how you do multiplication of numbers in a particular base. Is that clear?
Yes, sir.
Yes, sir.
Now what we'll do is let us do a few questions discussion. This is something which I feel is more important rather than just going to theory. So first one, represent BC7 in base 15 in base 7. So take 2 minutes, all of you, to solve it, and then I'll solve it. For each of these questions, I want you all to first try in 2 minutes. Answers, anybody? Answers?
So 10522.
Okay. I'll solve it and I'll see. Others, anybody else? Everybody getting the same answer or different answers?
Yes,
Okay. Let us try solving. BC7. So first, we'll convert from base 15 to base 10. So how do we do that? What is B? B is 11. 11 into 15 square. C is 12 into 15. And then you have 7. So 11 into 15 square is 2475. 12 into 15 is 180. This is 7. So that is 2662. So your answer is 2662. But this is in base 10. Now what do you need to do? Get it in base 7. So again, so how do you convert from base 10 to base 7? Keep dividing. So if I divide by 7, how much am I getting? 3. 21, that is 56. 56 by 7 is 8. And then 380. So the remainder is 2. Then again, divide by 7, you get 530. So that is 54. Remainder is 2. Again, you divide by 7, you get 7. Remainder is 5. You divide by 7, you get 1. Remainder is 0. Again, you divide by 7, you get 0. You get 1 here. So your number is 10522 base 7. So that is the right answer. Next one, convert it to base 4 and base 16. So take 2 minutes to solve both of them, base 4 and base 16. If you convert, how much would it be? So this is your number. What will be the answer in base 4? Anybody? Base 4?
So 1 2 2 1 2 3 1 1.
4 1. First digit is?
1 1.
4 1.
No, actually 1 2 2 1
1 2 2 1.
2 3 1 1.
Okay, and in base 16?
I haven't done that yet.
Okay, so let's look at base 4. If you look at here, I'm getting 0 1. 0 1 is 1. Again 0 1, that is 1. This is 1 1, which is 3. This is 1 0, which is 2 plus 0, that is 2. The 0 1 is 1. 1 0 is 2. 1 0 is 2 1. So the answer is 1 2 2 1 2 3 1 1. That is for base 4. Next comes base 16. So how do we do base 16?
We can take groups of 2 from base 4.
Okay. How do we do that? One into 4 plus 2, that is 6. 2 into 4, 8 plus 1, that is 9. 2 into 4, 8 plus 3, that is 11, which means B. 1 into 4 plus 1, that is 5. So the answer is 6 9 B 5. Is this clear? How you could have done base 11, 16? Simply 1 into 4 plus 2, that is 6. 2 into 4, 8 plus 1, 9. 2 into 4, 8 plus 3, 11. That is B. 1 into 4 plus 1, that is 5. Okay? I hope this is clear to everybody.
Yes.
Sir, I have a question here.
Yes.
So if we are asked to convert a binary number into a base, let's say an odd base, like base 17 or base 19, we convert the binary number into nearest base of 2 power, is that right? And then convert that base into whatever the base which is required, right?
You could have converted directly to base 10, na? That is easier.
Yeah, base. I mean, we can convert into
base
2
10
powers.
and then go to the base odd.
Okay.
That is easier, right?
Yes.
Only if there's a direct way, like if it's a power where you can take 2 digits at a time, 3 digits at a time, or 4 digits at a time, then you can go by the direct approach, the way we've shown here. Otherwise, you can go back to the normal method.
Okay.
Okay. Next question. The teacher asked Naman to rewrite all possible positive integers between 1 and 840 in base 5, base 6, and base 7 notations respectively. How many of these integers will end up with having a non-zero last digit in each of these base notations? So the options are given: 460, 380, 360, and 480. Answers? Answers, anybody? Can anybody say what does non-zero last digit mean? What does non-zero last digit mean?
It should not be divisible by these numbers 5, 6, and 7.
That is right. Any number in decimal notation, if I write which ends with 0, like 120, 60, 70, all of them are multiples of 10 or divisible by 10. Any number which does not end with 0, like for example 82, 138 and so on, they are non-zero last digit, which means in decimal notation, which means they are not multiples of 10. So non-zero last digit in any base n would mean they are not divisible by that n number n. So what is the question basically saying? The question is basically saying how many numbers between 1 and 840 are not divisible by 5, not divisible by 6, not divisible by 7. So in base 5, what are the last digits possible? Anybody? What are the last digits possible? 0 to 4, correct? Out of that, only in one case is it going to be 0. In all the other cases, in 4 out of 5 cases, it will be non-zero. In case the last digit is 1, 2, 3 or 4, then it is non-zero. Only if it is 0 in the last digit, we will not be considering, we'll be considering all the other scenarios. Or if you simply put the probability that a number is divisible by 5 is 1 by 5, the probability that a number is not divisible by 5 is 4 in every 5 numbers are not divisible by 5. Similarly, 5 in every 6 numbers are not divisible by 6. 6 in every 7 numbers are not divisible by 7. So the answer will be 4 by 5 into 5 by 6 into 6 by 7 into your total range of numbers, that is 1 to 840. So this is cancels out 4 by 7 into 840, which comes out to be 480. Hence the answer is option D. 4/5 is the probability that a number is not divisible by 5. 5/6 is the likelihood a number is not divisible by 6. Or if you look at last digit wise, there are 6 possibilities, 0 to 5, out of which 5 of them, 1 to 5, are non-zero. So the numerator is 5. Denominator is 6, because 0 can also be a digit. Similarly, for base 7, there are 7 possible last digit possibilities, out of which non-zero is 6. Hence, the fraction is 6 by 7. Is it clear how we got this answer?
I have a question here.
Yes.
So in this example, luckily 840 was divisible by 4, 5, 6, and 7. So sometimes I have seen
divisible by 5, 6, and 7.
Yeah, 5, 6, and 7. So
right.
I have seen questions like these where not divisible by 5, 6, and 7, and in some of those the number that is given, like 1 to 840, or the range that is given, that is not completely divisible by these denominators.
Okay.
So
if
what
you
do
look
we
at
do
the exams, what they'll do is they'll either give you numbers exactly divisible, or they'll give you 1 or 2 numbers which are away from the range. For example, had they given you 1, 2, 850. Okay.
Yeah.
In that case, you can just 1 to 840 is done, correct? And then you need to manually check for 3-4 numbers at max. They'll not give you more than that.
Okay.
Because otherwise you have to manually count. They'll either give you 840 or they might give you till 850 at max. That they won't give you 10 extra numbers. They'll give you 1-2 extra numbers they might give you, just to put you away from the divisibility check.
Okay, and what about the questions in which range is given, like 200 to 400? So we just take for 400 and then...
It doesn't matter. Let's say I take the range of 92 to 101. How many numbers will be divisible by 10?
1 only.
Why? Because 1 by 10 into 10 numbers. It doesn't matter whether I change the range to 37 to 44, 46. The range will still be 1 by 10 into 10. In every 10 numbers, you'll get one number, right?
No, I was not talking about this range. I was talking about like in this, that 1 and 840 range is given. So what happens if, for example, 400 and 840? I was asking about that range.
So I'll give you an example. Let's say in the question they've given you 400 to 820. This is a possible question they can ask you in the question exam. 401 to 820. Okay?
Yeah.
Huh? So that is how many numbers?
That is
420 numbers.
Yep.
So simply multiply this by 420. That's how maths works anyways.
Okay.
The same thing that we are doing here. Doesn't matter whether it's 37 to 46 is 90 to 101. Which range you are picking up numbers from. Numbers are uniformly distributed. Divisibility by every 5 numbers you write, any 5 consecutive numbers you write, you'll get one number which is divisible by 5. Any consecutive 6 numbers you write, you'll get one number which is divisible by 6. Yes or no?
Yeah.
So that is the simplest thing that I'm doing. Nothing else. So this will work in every question.
Okay, thank you.
This one, try solving. So the kilometer reader is reading 6219 kilometers. But the reader has the issue that it always skips the digits 4 and 6. So the question is, how much is the actual kilometers that the car has traveled? Even the reading is 6219. You should have answered it by now. You should need, instead of wasting time solving, you could have answered it by now. Is 62919 a possible readable value in the kilometer reader? Is 6219 a possible allowed value in the kilometer reader?
No.
So the answer would have been not possible or cannot be determined. Now let me change the question and make it a little more simpler for you. Let's say 4 and 5 are not allowed. Then this is allowed. Then this is a permissible question. Yes or no? Or will still it be cannot be determined? In case 4 and 5 is not allowed, but 6 is allowed, then will this be still cannot be determined or will it be permissible question?
Allowed.
Okay, allowed. Then try solving. In that case, what would have been? So 6219 is the reading, but the kilometer range, it always skips digits 4 and 5.
Is 8221 the answer?
Eight two two one is one answer. Others?
Sir, 4975.
Okay, I'm getting a different answer here, 4975. Any other answers, anybody?
One 167.
So I'm getting different answers. Okay, let's try solving this. Okay. So
Right.
let us look at what the readings map to. 0 to 3, there is no problem in both the actual readings as well as in kilometer reader. 0 to 3 is the same. But the problem happens after that. There is no 4 and 5. So what is actually 6 can be written as in base 8, where you have only numbers from 0 to 7 allowed. 6's can be denoted as actually 4. 2 and 1 is 2 and 1. 9 is going to be denoted as 7. So if you are writing numbers in base 8, given that this kilometer reader can only process 8 digits, if I represent it in base 8, this number becomes 4217. Why? 6 becomes 4 because after completing 39999, instead of it becoming 4000, it will read as 6 1000. So 6 is basically equivalent to 4. Is that clear? Because there is no 4 and 5 allowed, after 3999, instead of reading 4000 kilometers, you'll start reading as 6000 kilometers. Also, when I'm saying the digit is 9, the digit is effectively 7. So the number is 4217, but this is the number in base 8. Whereas actual reading I need, that is in base 10. So what do I do? 4 into 8 cube. So that is 2048. 2 into 8 square, that is 128. 1 into 8, which is 8. 7, which is 7. So 2048 plus 128 plus 8 plus 7. So that comes out to be 2191. This is your reading in base 10. Is it clear? Any questions, anybody? I see everybody gave a different answer. Any questions, anybody?
So can you explain the first part again, please?
So the meter is reading 6219. Okay. After 3999, what will the meter read? It should have ideally read 4000, correct?
Yes.
But since digits 4 and 5 are not supported, it will directly move to 6000, right?
Yeah.
So basically, instead of what is actually digit 4, it is going to directly to digit 6. So what is 6 is basically nothing but actually 4 in the first. So basically, actually the digit 6 is nothing but 4. Actually digit 9 is nothing but 7. However, 0 to 3 will not be impacted. They would still be written as 2 and 1 respectively, because there is no problem there. The problem happens for digits after 5. They are all getting increased by 2. Why? Because the display has a problem.
Okay.
So 9 is the largest possible number in base 10, where the largest possible number in base 8 is 7. So 9 is nothing but effectively 7. Is that clear?
Yeah.
Next one, largest possible 4-digit perfect square number in base 9. Anybody? How do we do this? So try solving this.
Sir,
Yes.
is this the largest possible 4-digit decimal number in base 9 or the largest 4-digit perfect square in base 9? Like, do we have to calculate the decimal number that is 4-digit and a perfect square in base 9 or just the base 9 bala part?
No, no. Get a number in base 9.
All right.
So the answer I got is 1277.
Such a small number. This
I
is
don't
a
understand.
I hope you understand. One starts with only 1. I'm asking for the largest possible. I hope you realize your number is quite small for a 4-digit number.
4-digit number in base 9 or 4-digit number in base 10?
Base 9, base 9. Even base 9 allows digits up to 8, right? Any other answers, anybody? So had this question been in base 10, what would I have done? Simply 99 square. That is 9801. Correct? That is what I would have done had the question been in base 10. Right? Does everybody agree with me? Had the question been write the largest 4-digit perfect square number in decimal notation, I would have simply done 99 square is 9801 because the next number is 100 square, which becomes a 5-digit number. Correct? That's what I would have done. So similarly, here again, what would I have done? Largest possible 2-digit number, uska square. In base 9, the largest possible 2-digit number is 88. So simply multiply 88 into 88. Will this work? Yes or no? Will this work? Yes or no?
Yes, sir. True.
I think so.
So what is 88 into 8? 704. So if I divide 704 by 9, how much am I getting? Use your calculator. 704 divided by 9 is 78. So 9 into 78 plus 2. So this will be 2. And the carryover will be 78. Next, 88 into 8. That is 704. 704 plus 78. That is how much? 782. Again, you divide it into 9. 782 is 9 into how much? 704 plus 78, that is 782. If I divide by 9, it is how much? If I divide 782 by 9, how much am I getting?
So why you carried over 78?
Because this is 78 times, no?
Oh, like I can write that into something into say 81. That 704 I can write like something into 81, then something into 9 plus 2.
So 81 is again a multiple of 9, right? '81 is no different from a multiple of 9, right?
Correct, but
what? Tell me. $99 into 99 is how much? 99 into 9 is? How much is 99 into 9? 891. So what do I do? 891 and carry over of 89. 891 plus 89. That is 980. This is how I do it, no? Simple if I had done in decimal. This is what I would have done. Yes or no?
yes.
Then what is wrong in what I'm doing? So 782, if I break it into 9, how much am I getting? That is 86.88. That is 86 plus 8, which means '86 will get carried over and you'll get 8. So that is 82 and a carryover of 86, which will come at the start. 8682 will be your answer. Is it clear? The same thing here, what I was getting was 980. Here what I was getting was 980 is equal to 10 into 98 plus 0. Hence we put 980. Here we are getting 89 into 86 plus 8. So I'm getting 8682 as my final answer. Clear?
Yes, yes.
First I got 704. 704 is 9 into 78 plus 2. So I put 2 here, 78 carry over. 700 again 704 plus 78, that is 782. 782 can be written as 86 and 8. So 8682. This is the largest 4-digit perfect, and you can see it's a very large number as well in the 4-digit numbers. Given that, you're only allowed digits from 0 to 8. Okay, clear?
Sir, one question, last one. 704 can be written as 862 in base 9.
Did we do a calculation? 704 divided by 9.
No, yeah.
That is 78 and 2 is the remainder.
That is okay, sir. I'm asking is 704 can be written as 862 in base 9. So when we multiply, the 2 is the unit digit, we'll keep it there. So the carryover should be 78 or 86.
704 is only 782 na, in base 9.
We can do 9 square, na, sir. We can do 9 square there. That is 2 is 9 to the power 0 plus something into 9. Oh, yeah, got it.
Why you want to do that? Ultimately you're getting in powers of 9, na?
Correct, sir. Got it.
Next one. So it will end with the 00 sequence in exactly one of these two notations.
Sir, B.
D. No.
I'm saying B for Bombay.
That's B for Bombay. I don't think so, but maybe. Let's see. Any other answers, anybody? So what does end with the 00 sequence mean? When will a number end with 00 in decimal notation? When will a number end with 00 in decimal notation? When it's a multiple of 10 square, that is 100, right? So in base 6, it will be when it is a multiple of 36. In base 11, it will be when it is a multiple of 121. So basically the question is saying it is either a multiple of 36 or 121. So what is the probability that a number is either a multiple of 36 or a multiple of 121? So there are two possibilities. Either 36 is a multiple, 121 isn't, or 36 isn't, 121 is. In this case, the probability is 1 by 36 into 120 by 121. In the second case, the probability is 35 by 36 into 1 by 121. If I take common, I'll get the denominator as 36 into 121, the numerator as 120 plus 35, which comes out to be 155 divided by 4356. Hence the answer is option A, that is 155 divided by 4356. Is this clear?
Yes.
So the denominator is nothing but 6 square into 11 square. Just like everything you can visualize as what you would have done in decimal notation. In 00 sequence means multiple of 100, that is 10 square. Similarly in 6 notation means multiple of 36. 11 notation multiple of 11. 11 square, that is 121. This one, so it ends up having exactly 6 digits when converted to a different base, that is B. What are the sum of all possible values of B? So try and solve this, everybody.
$17.
Okay, any other answers, anybody? So how do you do this? Look for 6. First of all, if the number of digits is increasing, it means the value of B possible must be less than 10. So B must definitely be less than 10. And of course, it should not be very less than 10 also. If it is very much less than 10, then you might have having 7, 8, 9, 10 digits. It must be slightly less than 10. So now, can base B be 6? Can base B be 6? If I look at 6-digit numbers in base 6, the minimum number possible is how much? That is 6 to the power of 6 to the power of 5. And the maximum possible value is 6 to the power of 6. So what is the range? 6 to the power 5 is 7776. 6 to the power 6 is 46,000 something. Which means base 6 is not satisfying because 9999 doesn't fall in this range. Next, let us look at base 7. What are the numbers possible in base 7? What are the possible 6-digit numbers possible in base 7? 7 to the power of 5 up to 7 to the power of 6. So what is 7 to the power of 5? 16,807. What is 7 to the power of 6? 117K. So does 99K fall in this range? Yes, which means 7 is satisfied. Similarly, if I check with 8, 8 to the power 5 to 8 to the power 6 range, you get 32,000 up to 256,000, where again 99 falls. So both 7 and 8 satisfy. Similarly, if I check from 9 to the power 5 to 9 to the power 6 range, that is 59K up to something like 5.4 lakhs, where again 99,000 falls in. So 9 will also satisfy. The 3 numbers are satisfying: base 7, base 8 and base 9. Note, in base 6, the range possible is 7,000 till 46,000. So 99,000 does not satisfy. Hence the answer is 7 plus 8 plus 9, that is 24. Is it clear why it is 24? So in every base I'm checking what is the possible 6-digit numbers that are there. And what are those values in decimal notation? What is the possible 6-digit numbers in decimal notation? How much am I getting? Is 999,999 falling in that range? If it falls, then it will be counted like it is counted in 7, 8 and 9's case. It is not counted in 6 and below cases. Which means to write in base 6, you would have needed more than 6 digits. The last question for today is this. Add these numbers in base 9. 776, 541, 328. Add these numbers in base 9. This is the last question for today. So this is an easy one to end the session. Answers?
G21.
321. It's already 776 is one number. So it'll obviously be more than 776.
G.
1756.
G.
You don't have G in baseline. 1756 is the answer.
Yeah.
How much?
1756.
1756. Okay, let's just try adding. 6 plus 1 plus 8, that is 15. 15 is basically 9 plus 6. So 6 here, carryover of 1. 1 basically means carryover of 9 means 1. 1 plus 7, 8 plus 4, 12 plus 2, 14. 14 is 9 plus 5. So 5 here, carryover of 1. 1 plus 7, 8 plus 5, 13 plus 3, 16. 16 is 9 plus 7. So this is 7, carryover of 1. So it'll effectively become 1756 base 9. So that is right. The answer is indeed 1.